Okay, so welcome to Open Topography webinar, and today we're going to talk about, we're going to continue our sequence of webinars, and today's is going to be about 3D visualization of topography data using Open Topography's Potree viewer and CloudCompare. And so this is the fourth of a series of webinars we've been doing this spring, so right now we're here kind of in the middle on the fourth one. Next week we'll be doing topographic differencing and kind of continue on through these different topics. And then I want to remind you, if you haven't been able to catch one of the earlier ones, or if you want to refer to these in the future, we have them all on the Open Topography YouTube channel. So just look for them there. So this is a Zoom webinar. Only the presenter and my colleagues who are the moderators will be able to speak. If you have questions, use the Q&A option, and we may or may not have the chat functioning, and then some of the other people on the webinar will try to get to your question if they can as we're going along. Otherwise, we'll save them for the end. So here's the agenda. I'm going to dive right into it. So I'm going to remind you about point clouds. So today is really about point cloud visualization, not about digital elevation model visualization. Then I'm going to have a main chunk of a demonstration about Open Topography and the Potree viewer that's available inside OpenTopo that you can use inside of a appropriately enabled browser. And then we'll go outside of OpenTopo into CloudCompare, and I'll show you a few desktop point cloud operations. So just as a reminder, and this was covered in one of the last webinars, is a point cloud is a fundamental LiDAR data set. So these are discrete XYZ points with various attributes, including return number, classification, GPS time, intensity, and sometimes color. These and the formats for point clouds that we usually talk about are LAZ is our main one, which is a highly compressed version of the LAS format. And so colorized point clouds are basically a merger of the LiDAR point clouds with some imagery that was taken at the same time that then allows us to colorize the points if it's a LiDAR data set, or it's a kind of a fundamental outcome of a structure from motion data set. And so these photorealistic point clouds are really nice for our visualizations, and we'll see them today in a demo, but not all point clouds have the RGB coloring, and not all point clouds have all of the same attributes. So that's something you just want to be aware of. And just while we're looking at point clouds, just to remember that sometimes the point clouds will have a classification attribute, and these numbers will be assigned to that attribute. And so a lot of times what we're looking at, especially as earth scientists, is this number 2 classifications. That's our bare earth. That would be the ground, or at least what we think is the ground. And so not water, vegetation, and so forth. And so we will just keep our eye out for that. So there's many open source tools that are available for working with point clouds outside of Open Topography, and we're going to just demo the CloudCompare toolkit, but there's the LAS tools available from Rapid Lasso, the PDAL toolkit, and Python-powered LasPy PDAL can be powered in Python, and Whitebox. So I'm going to talk about OpenTopo first, but if you want to, and you can multitask, but of course you're going to pay attention to what I'm saying, is you can download the CloudCompare in the background and kind of get that ready. But in the meantime, I'm going to start inside Open Topography using Potree. And so this is not obvious from the main web's page. I will just say that if you go to the main web page down here in the lower right, this tweet is from Marcus Schultz, who is the Potree lead developer. So it's kind of interesting coincidence there. So and also on Open Topography under the Learn tab is something we have called the Open Topography Potree Point Cloud Treasure Hunt. So this is a really nice little way to learn about Potree if you don't learn enough from me today. And so it has a little treasure hunt, so a couple of tasks that you or people you want to learn have learned Potree can follow, and then it has hints and answers and this nice little well narrated tutorial at the bottom. But in the meantime, and to do something different, so it's not what's in the tutorial that's already there, I'm going to go, I've gone inside of OpenTopography, and we've already demonstrated how to do this in the prior demo, so I won't go through it again in detail, but I went to the OpenTopography interface, and I went to this area in Northern California that's just to the west of Santa Rosa. It's a place where there are some large trees, some old growth trees. So I wanted some tall features. And so I selected this area and I selected the point cloud. And so I went through the interface of OpenTopo, and I wanted to make sure I clicked on this point cloud visualization. So you have to have this clicked if you want the Potree to work, because it computes the data in the right format, in a tree format. That's where that part of the name comes from, that allows us to visualize these data in the browser. And so here's a view of that site. We'll see it in a moment in 3D, but here's in 2D with satellite imagery. So you see there's going to be a pond, a field, and some tall trees. So I ran the model, and when I'm inside the browser, I'll click on this show view 3D point cloud in our browser. One thing I do want to point out, and this is another key advantage of using OpenTopography, is we do have very good metadata. And one thing about these data is that they're in feet. And so that's because it was acquired for a county project, Sonoma County, and their geospatial system is in state plane. And so the vertical elevations or vertical units are feet. And so you'll see that in Potree, it's kind of default as meters. So we'll just need to keep that in our mind when we start measuring things. So let's look at this. The next slide is here. So Potree is a free open source WebGL based point cloud renderer for large point clouds. It comes from Markus Schutz, who is at the University of Vienna, and his colleagues. There's a GitHub site for it, and it's designed for very high performance visualization of 3D point clouds, and is really impressive, I think, because it liberates us to, as long as you have a, your browser is enabled, you should be able to do this on any machine. So you don't have to have an external app like CloudCompare, for example. So what we're going to do, we're going to visualize these points by a couple of different characteristics, and then we'll get a tour of the interface. We'll make some measurements. We'll make a topographic swath profile, and we'll filter the points. So I'm going to just pop out of this presentation for a second so I can grab that URL. So if you want to try to follow along, you can grab it from this chat here. Let me send this to everyone. Okay, so let's go. And the key thing is that this doesn't really, it only works if you have the right browser, if it's WebGL enabled, which means mostly Chrome and Firefox. And I have to admit, actually, on my own laptop this morning, I couldn't get it to work completely in Chrome. So, but it seems to be working fine in Firefox. So if you're having trouble, switch your browser. So this is the job results, and we'll come back to this LAZ file later when we look at CloudCompare. There'd also be the DEM if we wanted to look at the raster product. But right here, what I wanted to look at is the 3D point cloud in our browser, supported on Firefox, Chrome, and other WebGL2 browsers. So let's click on it. And so luckily, I have something. So to me, it's really exciting. When I first saw this, I was like, wow, that totally satisfies the initial needs for visualization and simple analysis of point clouds in the browser. And so this is on a laptop. It's not that fancy. It's a few-year-old Lenovo laptop running Windows 11, and I'm in this relatively recently updated Firefox browser. But look at what I can do. And here I have, this is, I think if we go back to the site here, we have just 2 million points. So it's not a huge data set. Whoops. But and it is important to realize that performance will degrade with bigger numbers of points. So you want to be cautious there. So we've already had pretty good success in our demo, although maybe famous last words as it freezes. There we go. Okay, so the main thing is then over here on the upper left of our screen are two things. One is this little green share, lets you copy a shareable link if you want to send this to someone. But then here, this little 3 lines opens up a bar which has a bunch of controls. So let's just make them all small and we'll go through them sequentially. So first is if you look at appearance, this default's pretty good. We'll talk about what it's colored by in a moment, but if you're having any performance problems, you can decrease the point budget, and that just makes it a little easier to render because it basically will render fewer points. So I'm going to go back to most of them. And you can play around with field of view. The iDome lighting is a really nice kind of shading tool that lets us see the points a little bit better. So I like to leave that on. You can change your background style if you want, and so forth. So that's the appearance. Now let's go down to the scene control. So we'll go back to tools in a moment, but in the scene control, we can see kind of what we've got here, which is mostly just point clouds, but there's a lot of work you can do inside of this Potree browser system. And I won't demo all of them, but you are welcome to explore. So we can change point sizes and the shape or little squares. So right now we can see we're color coding by elevation. So one of the things is I can change the scheme. So this first one versus this one. So we can change our color schemes, and this goes especially for elevation. And you can even kind of highlight a certain range here in real time. So that's pretty nice. And then we can go down and look at our other attributes. And so the one that this one has, because of the data set preparation, is it has RGB. So this to me is really exciting. It's a 3D view of the colorized point cloud. And so we get a sense of this field, maybe grapes or something in the vineyard, these big tall trees, probably old growth, and then some of the structures in the field. You can see the pond here didn't get many LiDAR laser returns. This the water either just reflected them speculatively out of the ability to be returned directly to the sensor, or they were absorbed. So that's our kind of colorization. Other things we can look at is intensity. So this is the laser return intensity. So how bright was the target in that particular laser wavelength. So mostly these are pretty bright targets. You can see it looks like the ground is a little brighter than the, I guess if those are the grapevines. You can also see the orientation of the laser scanner and the points. Another thing we can colorize by is classification. And so this is a very nicely classified data set, which includes the ground points. The structures are the orange, and the brown is the ground points. Gray would be unclassified, so many of those might still be ground. And then the green is obviously the veg. So we'll come back to playing around a little bit and filtering this by classification later in this demo. And then other things you can look at, for example, is the return number. So you can look at, for example, the yellow would be a first return. And so when we're in the simple landscape of just the ground and the small vegetation, we're just getting one return. But you can see in these trees, as I zoom around, and I'm using my middle roller on my mouse to zoom in and out, and then the left mouse rotates, right mouse button pans. But as I zoom into this tree, I can start to look at the colors, and I can see how that single outbound pulse, when it goes through some vegetation, basically produces multiple returns. So we're going kind of from the early returns being yellow to maybe second return is red to third return is blue, and there looks like even there might be more than that with some green returns. So this data set, was recorded in such a way that we had the return number as one of the attributes of our point cloud. You can also see interesting sort of shape of this site. It's actually on a ridge top, so really seeing the top of the ridge there. We'll come back to that in just a moment. So that's our scene. And so the next thing is tools. So you see I close my scene tool. I'm opening up my tools tab. And I want to go back. Actually, before we do that, let's change our display attribute back to the RGB. And so let's make some measurements. So this is where this starts to become pretty useful. So let's say you wanted to know, how tall is this tree? So if I go to, I make sure I've clicked on the point cloud there, and I'm going to click on this tool right here, measurement tool. And what it's going to do, it measures it point to point. So you have to click on a point and sort of snapping to points. So let's click on that top one. And as I pull down to the ground, I'll click over a little bit on the side here. So we get a diagonal, distance, but this particular tool gives us that height. So it says 124.96 meters, but remember these data are in feet. So just the labeling here is assuming that most of these data sets are in meters, which is correct. But so this is 125 feet tall. So divide by 3 approximately for how many meters it is. So it's a pretty big tree. So that's useful. And when you're done measuring, you just click on the X to get rid of that. So let's go see how tall is this building here. If you wanted to measure a height of like the height from the top of the building over to the ground, looks like it's about a 20 feet tall, 22 feet. That's interesting. And so we can so that's just the height measurements. So we can get the other tool here, which is a distance measurement. So let's say we wanted to measure how long is the top of this building. So it's 140 feet long. And if I right click, I end that measurement. Also, if I had kept clicking, I could measure distance along a path. Let's go over to our little pond. So let's see, one to know, well, how wide is the pond? And just click here. Maybe you want to know from like the top to the road. So it's 475 feet wide. So let's close that. Now, what if you wanted to know the area, the surface area of the pond? We can, in the same view, click here, get the area measurement tool. So I'm going to do it a little bit quickly. So I'll put these vertices out kind of speedily. But what you can see is I'm, sort of dynamically getting that area. So remember, these are in feet, but so it's 78,000 square feet is the top of the pond. So that's can be quite useful and may answer some questions that you would have very quickly. And again, the advantage is you don't even have to leave the browser. Okay, so one of our what I think is a really cool capability is if I rotate like this, let's say I wanted to understand a little bit better what the ridgetop shape is. So I'm going to kind of come in like this. I click on this tool. It looks like an M. It's a height profile. So click here, and I'll go across just the ridgetop and click again. And you see it wants me to carry on. So if I right click, I'll stop. And now if I go down towards the bottom of this view, you see show 2D profile. And so it loads it up. It doesn't want to show it. So this was an error I had earlier today, and it's a little bit frustrating. And so I think, I'm not exactly sure what happened here. What I had done was kind of modify and resubmit this job. And so maybe the little Potree gets a little stale. So I'm in there, I'm just gonna rerun this. I'm not gonna calculate the 10 in this case. See how I've already done it twice. Run that demo, whoops. So as I said earlier to my colleagues, sometimes these demos are meant, the kind of error is meant to help you learn. So for whatever reason, it doesn't want to draw, and it's not a problem with OpenTopo. I think it's a problem somewhere between my browser and the production of that Potree file. So we can, let's just try one more time. So we'll clear that. Let's try again.
Well, you might try a wider swath too. You know, you can control the swath with. I don't know if that.
Yeah.
If you grab more points, that might work.
Let me try that. I'm gonna click on a few more vertices. Okay, so I'm in, and this width here, it's 9.48 feet. So let's try a 50 feet wide. So you see that nice wide swath. And let's see if it works. So if we don't disturb it, it sort of pulls the points in. You can see them coming in on the top there, but they're not displaying. And I don't quite know why this is, but this is one of those little idiosyncrasies of this software. And so let's just quickly see if our job ran. Okay, here's the new one. So I'm gonna go back. Whoops, sorry, I keep jumping to the wrong app. I'm gonna kill that version. And let's try this one. Okay, it's our same data set, but just freshly computed. And so if I go back, let's get my coloring by RGB and close this, open the tools. This is also how you learn, right? You have to do it like 20 times. Get that tree in there, click enter, and now right click to close that. And now let's go down, where is it, to the scene and show the profile. It's not showing, so I guess that solution didn't work. What I can do, and what we have in here for our demo is in samples, you can go, for example, to one of these like granite dells. I know that one. So just dump that other model, and usually this one works. So if we go to this data set, which is in Arizona, and if I come into this area where the creek is, I do the same thing. So let's get our tool available. Click across the little valley there, right click. And if I go down to show the profile, there it is. So I apologize for, I don't know why it doesn't want to work in that example. I did get it to work earlier, you have to believe me. But we can pull this down, and let's pull our model up a little bit so we can see it. And I can make this wider, as Chris has suggested. So now these data are actually in meters. So let's make it a 25 meter wide. Oh, it's very wide. Maybe 250. There we go. So we could get a nice profile of this valley, kind of a valley cross section there. And you can also, as you move the mouse across the profile in the lower window, it's linked to the upper window. You can see where you are in that profile. So that's kind of nice. And we can see, for example, this nice granite hill here. So that's the profile tool, which you can see is a little finicky. And you just have to play with it. I know it works. Sometimes I have to switch the browser. But I'm going to go back now to our original file, and I'll just get you the shareable link if you want to get the fresh one. Maybe it'll work for you. So here we are. We've done appearance. We've played with our tools. And so the last thing then that I wanted to show was if you go to your display attribute, change the classification. And now let's go to filters. And so this is nice because it automatically populates this classification with what's available in this particular data set. And so we can start turning things on and off. So first, let's turn the unclassified off. So those are those gray points. And so you can see there's actually quite a bit of data in here that the classifier didn't know what to do with. And it's probably because it was these low veg, the grapevines maybe. And then high vegetation, that's those green ones, which makes sense, big trees. These pink ones were some kind of a noise. So they didn't, the classifier was a little confused with them. Some are high, some are also maybe a little bit low, so we can get rid of those. And so we have the ground and our buildings. And the water, even though we know there's water here, it wasn't classified, maybe because there were no points on it. But so then this would be the points that we think represent the ground surface. And from this, you could make something, for example, like a digital terrain model. Here you can see, interestingly, this little gully coming in there. Let's kind of look at it from the side, which you might not have noticed with, for example, if we put the unclassified on, it's a little bit hidden. But then you think, oh, okay, I can start to see it better. They didn't bring the grapevines into that little valley. So this is another really powerful capability for the Potree viewer, is to visualize the different classes of points. But again, it depends on the input data set. So depending on how your data are classified or not, you'll have different choices here. A common thing will be just ground and unclassified. So the first step in many classifications is to just do ground and everything else. And so that would be maybe one set of choices for a data set you would take a look at. So that's the where I want to stop with the Potree viewer. And I'm just checking, looks like, is it possible that the noise in the LiDAR could be from birds? Yes, it can be. Let's look at them. So, could those be birds there? Hard to say. I mean, they're in the trees. So probably in this case, I don't think so. I think they were just points that the classifier didn't know what to do with. More likely, if maybe this one that sits over here by itself, that's more likely in my view to be a bird. So good question. All right, so let's move on from Potree. And just like many things, the best way to learn is just play with it, and then you'll become better at it than I am. So I'm going to close this. I'm going to go back to my presentation briefly. So we did this. So now we're talking about CloudCompare. So CloudCompare is a application that runs on Windows, Mac, and Linux. It's really nicely done. It's free, but if you use it a lot, it's important to support the developers. And it's produced by French colleagues, and I forgot his last name. I apologize. And first name is Daniel, and at least at times he has worked for the French electric company. And I think this tool was in part developed with their support, but also now is more widely supported by the community. So big thanks to CloudCompare and its developers. And so what we're going to do now is we're going to, if you go back to that link I sent you from OpenTopo, remember it had this LAZ file in it. So let's just go grab again this output I had from earlier today. We can just click it to demo it, because I have it here, but let me just demo this to be kind of thorough. Paste it in. That's what it looks like. Now, if you look at this in the future on a video, this may, we don't keep all the jobs as permanent in OpenTopography, so you might have to modify and resubmit, or just do your own. But now what I will do is I'll download this LAZ file, and I actually have already downloaded it to my desktop, but that's where I would save it. And now let's open CloudCompare. So I have CloudCompare installed on my machine. And so just let's open, and then we get a quick tour. So open, I'm go navigate to my desktop where that points.laz file is. And so you can see it kind of has a couple of dialog boxes at the beginning where you can choose what to import. I always just say apply all. So just kind of import everything. And then the next one is important, this dialog, which is to basically, these data, as you remember, are in California state planes. So they're in some complex units. And so they're very large numbers. And what this step does is it kind of translates it so the middle of the data set are at a simpler and smaller set of numbers, kind of like shifting the origin. So it shifts it to, you see on the right, more like 17 and 46 instead of 6,276,517. So we're just getting rid of these big numbers. It makes the computations a little bit faster, but it will remember that we made this shift. So if we have some products as we go and we save them, it'll put them back in at the end. So this, we want to say yes. So importing these 2 million points, and here we are. Should look familiar. It's our same site. Points are a little smaller here. So if you want to make the points bigger, up here it doesn't show on this screen, but you can just click plus here. So there's our site, nicely rendered in CloudCompare now on my desktop, and it has the scale. So remember, this is feet. And so this interface, what you see, your main thing you want to remember is this DB trees, kind of like a table of contents. So we want to see what's over here. And if we click on our point cloud, then down in the properties window, we see some interesting things. And so right now we can see it's colored by RGB, but it could also be colored by scalar field. And what that means is just whatever attributes are there for each point. And so then if I scroll down a little bit more, I can see, okay, number of points, that global shift, the point size, so forth. But you see the scalar field, there's 9 scalar fields that are in this particular data set. And I'm coloring by the point source ID, which is not particularly useful. But let's go back to remember our classification. There was what we looked at before. So the choice of the colors for the classifications is a little bit different than what we saw in Potree, but same visualization. I can also go back to, remember, I like that intensity view. So here's the laser return intensity. And if I go back up to the RGB, I can go back to that colorization. So we see that basic interaction with the data set. So there's a number of things we can do in CloudCompare that are similar to what we did in Potree. One thing we could do also is make some measurements. So if I come in, let's measure again just to make it easy, the width of the pond. So one key thing in CloudCompare is you have to always want to make sure you click on the data set that you're working with. So in this case, the cloud points. And then I click on this icon and it pops out a little bar, and we can see that then I can, measure this distance. So select 2 points and display segment information. So click here. And again, I have to click on a point. So if it misbehaves, then try again. So this gives us that exact point, which has this information about where it is, the local position, the global position, RGB color, etc. So I click a second time on the other side of the pond, and boom, I got the length in its, well, I have the length, which is 444 feet, and then the different components of that length measurement. And so that can be quite helpful for you to analyze some data. Okay, so let me just remember what sequence of things I wanted to show you was point attributes, measurements. Okay, so we made the measure. Let's talk about segmentation, slicing and scissors. So let's zoom out. So again, I'm using the middle mouse button to zoom, right mouse button to pan, left mouse button to rotate. Sometimes if you don't, it sort of rotates sort of where it thinks it's obvious. But if you click over here on this plus on the left side, and if you click on a point, like if we wanted to, for whatever reason, rotate around this house. Oops, I didn't quite hit it. You have to make sure you hit a point. There, no. Zoom in a little bit more. Did I get it? I'm still not quite getting it. Well, anyway, sometimes this works. If I hit the point just right, I can get it to rotate around a different rotation center, but somehow I'm not grabbing it right now. That's left to the participant. The icon for the measurement is this one over here. It looks like, I always think it looks like the, on an old sailing ship. It's like how you steer the ship or something. So that's called point picking. So you can do an individual point, the distance. You have to make sure you click on the right tool, so forth. So let's talk about segmentation. So the first thing we can do is make sure we click our data set to make it live. And I'm going to use this tool here. And what you get is this, it's a little bit hard to see here, but you have these really kind of bold looking arrows and kind of tubes. And so the tubes, if that's what that looks like, kind of rotates the box. And then arrows let you change the size of the box. So basically, if you look at then this yellow outline is our box that contains the points, but we can make that box smaller. So if I kind of grab just the arrowheads, and let's make it kind of really narrow. So if I wanted to just look at kind of this field and those trees, I would do this. And now you see there I have just that little piece of the data. And if I then click over here in this dialog box on this one thing where it says slice and export selection as new entity, poof, I click that button. If you look on the left, and then I can get rid of that tool. If you look on the left, we now have two files in our DB tree. And the first one's our original, and the second one is this little extracted item. And so that's pretty handy because it's a very efficient way to chop up your point cloud. And if you needed to now export this to do something with it, if you click on this and you say save, make it live, click on the save, you can save it as a CloudCompare entity.bin, which isn't that useful unless you come back into CloudCompare, but you can save it as an LAZ file. And so I could say this is a cut piece, save it back to my desktop, and I could get it again later. So I'll save it, original resolution, it put that global correction back in. And so I've got that little piece prepared. So let's so now if I right click on what we had produced before, I can get rid of it. So I'm back to the original. So that was a simple slicing tool. But what if you wanted to cut something out? Like sometimes I like to try to grab a tree. So if I come in on the top of these trees right here, make sure my data set is selected. I'm going to grab this tool that looks like little scissors. And so now what I'm going to do is I'm going to click each time I click with my left mouse button. I'm going to add a vertex to this little polygon. And now if I right click, I stop. And then on the tool at the upper right here, I'll just click on this one. It says segment in. It doesn't really matter too much because we're just going to cut this into two pieces, what's in and what's out. So I click that, and then I'll click the green button to do it. And so now it's pretty exciting. I have two pieces of data, and one of them is my set of trees. And so now if I was interested in these trees or some object in detail, I can maybe increase the point size a little bit. And I could go in and let's change the scalar field to not intensity, but return number. And so I can sort of study, teach myself a little bit about how does that work, the return numbers. I can play around a little bit with the color. So this is C current, it's blue, green, yellow, red. I could change that to blue to white to red, or brown to yellow, or something like that. So that's convenient as a way to analyze a complex subset of the data. So I really like the scissors a lot when I'm playing around with the point cloud. But I'm going to go ahead and go back to RGB. And what you can do is if you have two of them visualized, it looks like they're together, which is fine. And you actually can put them back together. If you shift select the two of them, this little tool right here will merge them back together. And it kind of keeps track of, oh, you did have them separated, so that's a new scalar field. But I'll go back to RGB. So it looks the same. It has a little bit of information that we did chop them apart. So later on we could extract maybe by that new scalar field. So so that's segmentation. And let's just show you really quick, one thing we can do while we're here is if you click on this tool, that gives us kind of the information about the data, kind of a histogram of what's being shown, which in this case is the RGB. If I click on something, if I expand that, was looking for this min max. And so now what I can do is if I go to my, oops, sorry, let's cancel that for a second. Let's change this color code back to this one, which is our new scalar field, which was the, did you or did you not select it? Now I can go to the min max tool, and and then also I want to see what sorry, let's just look at the values here. So I have some values of 1 and the rest are 0. Okay, so the ones, let's say if we wanted to get them, we can do this min-max filter, and I can say, all right, just give me the range of 1 to 1 and split. And so now I'm back to having the split, the original, sort of what wasn't in that box and what was in the box. So that's really another pretty powerful capability that we have inside of CloudCompare, is to do this segmentation by a range of values of a scalar field. So let's, again, I'm going to kind of put them all back together to keep it simple. So I've got them all in my data set. Whoops. Go back to RGB. Okay, couple more things I want to show you guys. Could I fill in the missing points in the pond with a specific value? Good question. I don't know, Charles. I don't think so. You can interpolate. If I have time, I'll show a little bit about how we might fill in that area by kind of making a raster out of these data. So let's hold that. Okay, so let me just go back. So the next thing I wanted to show you guys, so we did slicing and scissors. Okay, so thinning. So one of the things we can see, if we look down here, we've kind of duplicated, looks like we duplicated some of our data when we merged them. So I'm going to actually go back, file. I'm going to close that out. I'm going to open my original file again. Apply all. So this is good practice. Apply all. Pull them in. So we know there's 1.9 million points in the original data set. And oops, what happened here? Let's click on well, sometimes, again, these are mistakes meant for educational purposes. So I'm going to close that one and I'll open CloudCompare again because I don't know why it wasn't showing me the ability to kind of center. So now I've kind of cleaned things by closing and opening. And okay, phew, we got it all back. So I don't know what happened. Now, what I wanted to show you here is, so we know we have the 1.9 million points. If I click on the data and I look down at my properties, I can see right here, lower left, 1.979. But what if you thought, okay, I need these data to be a little bit fewer and more evenly spaced because they're kind of scattered, you know, depending on how they were acquired. They're not too badly spaced, but sometimes in other data sets, like if you have a terrestrial laser scanning data set, you'll have a lot of points near the laser scanner and just a few further away. So if you click on this, you make your data set live, and this little button here, that's some dots that are blue and red, we can subsample it. So I like to do this, which is, we sometimes call this thinning. So I'm going to thin the data, and I'm just going to take a point every 10 feet. So it's going to be very thin, but it's still a decent representation of the data. It's just a lot smaller. So if we look now, we only have 34,000 points instead of 2 million. And so sometimes this is adequate. This is a way to, you know, make your file size smaller, but also have the points be more evenly distributed. And that can be really useful for certain cases. So I'm going to delete that one. I don't need that. Let's go back to our original. And then the next thing I wanted to show you was, still have a few minutes. So we keep our over here on, so I've just barely shown the capability of CloudCompare, and there are many other functions, but one thing I'll show here under tools, under projection, is rasterize. So we can make like a little digital elevation model inside of CloudCompare. So let's do it. Right now it would be 1 foot. So let's do this as 10 feet. The active layer is going to be our grid values, the direction of Z. We're going to do kind of a local average to get the cell heights. And we're going to leave the any blank spots empty for the moment. So if I update the grid, it's a little bit hard to see, but if I zoom in, there's my digital elevation. This would be a digital surface model because we included all the points. Now, if I, let's do it again, but let's interpolate. And let me see, do I have to, there we go. Okay, I'm going to interpolate. And if I update the grid now, there. So remember, Charles, you asked, how would I fill the pond? If I interpolate as I'm making this raster, I can fill the pond. I can cover the hole in the pond and any other holes. And then what you can do, if you just look down here, let me make this window a little smaller so I can see the bottom of it. It's right at the very bottom, whoops, is raster. So I can export this height, and I can export it as a geotiff. So if I export raster H, so I can remember its height, and I'll show you this in a moment. We'll look at my ArcMap. We can import that as a geotiff. So so that's a handy way. I mean, I don't really make a lot of digital elevation models in CloudCompare because it's still, you know, just these points, really. It's still a point cloud. It's just a regular point cloud with a point at each center. Let's just look quickly at, sorry, I'm just going to bring my ArcGIS over, and you could do this obviously in QGIS, but if I go, remember raster H, okay, so one thing is that CloudCompare doesn't give that geotiff any actual projection information, so you would have to remember to assign that from the original point cloud coordinate system. But there it is. I've got a little digital elevation model in ArcGIS. So that's pretty handy. Okay, so then the last thing I want to show in the last couple of minutes is a couple of other plugins. And so if you look in tools and okay, plugins. So one of the nice things about CloudCompare is this ability for other developers to produce tools that can run inside of CloudCompare. So a really important couple of them, one's called Canupo, which you can see on the right on my screen, but also it's under here. So Canupo was developed by Dmitry Log and his colleagues, and it is a way to do some really advanced classification of your point cloud that might help if you're in a more complex environment than this sort of simple airborne laser scanning of a bunch of trees and some structure. He developed this that worked really well for laser scanning of the sides of some rivers, and he could classify rocks and plants. So that Canupo is a big, powerful tool. The other one that I won't talk about either is M3C2, which is another tool developed by Dmitry Log and his colleagues, which is a very powerful way of computing distances between point clouds in maybe a non-usual way. So we'll hear in one of our future OpenTopo webinars about vertical differencing or 3D differencing, where we're computing kind of the components of a rigid body transformation, so X, Y, Z, and rotations, which is very powerful. But M3C2 lets you kind of arbitrarily get distances, maybe from lateral erosion of a channel wall or something. So nicely capable inside of CloudCompare. And then one last one I'll just show quickly, is kind of fun, is this compass tool. So for let's say the geoscientists out there, if we go to the top of this structure, it's this building has kind of planar roof elements. So I clicked on the compass plugin, and if I click on this little tool right here, I can measure the strike and dip of the roof. And let me zoom in, I get the other side. And so what you can see, let me just close this. So what we can see is these two, and if I turn the point cloud off, I have two planes that were determined or computed by fitting a plane through a selection of points that was in that little circle. So I get the normal to that plane and this little planar segment, and these are the dip directions. So they give us the orientation in a kind of a standard format. So I'll show in a moment, there's a whole really nice demonstration of this for mapping a fold in some folded sediments that it was produced by Chelsea Scott. But I just wanted to show that capability as a plugin, as sort of a further demonstration of the power of CloudCompare. So that concludes this demo. I'll come back to my presentation just to finish things up. So we went through all these topics here in CloudCompare. We had a few errors, which hopefully help you as I figured out how to get through them, how you could troubleshoot. And so for more information on the Compass plugin, I point you to this OpenTopography Learn/Painted Canyon, which is a really interesting exercise that Chelsea Scott developed for using that tool to study some folded rocks that were imaged in a point cloud that was produced from structure from motion. So I talked a lot about CloudCompare just now. We also talked about Potree, which is inside of OpenTopography in the browser. There are these other tools, but hopefully you get a sense of the power of interacting with point clouds. Many people really just work with digital elevation models, or 2.5D, but the point clouds give us the real 3D information. That's kind of the fundamental data when we talk about LiDAR or structure from motion and our 3D environment. And so in the future, we'll talk about 4D point clouds. So how do we get distances between the point clouds? That'll be in the future webinar. And so with that, I want to thank everyone for your attention. Thanks to my colleagues for helping me out. And we have just a couple minutes if there's any final questions. Yeah, thanks. Somebody, Matt, was helping me. So CloudCompare was created by Daniel Giardio-Monteau. So thanks for that. I wanted to be sure to give him credit there. Yeah, so maybe I'll stop sharing. Is there any questions, comments? Let's see here. Thomas says zooming in Potree, set scrolling on mouse, will other options. I don't know how else to zoom. I mean, if you have like a trackpad, you can kind of zoom, I think, with 2 fingers on your machine, but mostly I use a 3-button mouse for this kind of work.
I'll just say that somebody pointed out that if in your example where you're struggling with the profile, it seemed to be related to the RGB attribute. So if you had flipped to an elevation attribute, it was displayed. So for whatever reason, Potree was struggling with the RGB. I don't know exactly why that is, but
yeah, let that be a lesson, right?
Yeah,
because remember then when I went to the Granite Dells data set, it didn't have RGB on and it worked. Yeah, so okay. Yeah. Sorry guys for that error in the demo, but we learned something. Anything else? Let's see, hand is raised. Lin Xiang, question, do you want to ask or maybe just type it? Allowed to talk. Go ahead, Lin Xiang. Question?
No, I don't have any questions.
Okay.
So, yeah.
Thanks. Okay. Any other questions?
I guess as we wrap up, I also just point out that CloudCompare has really good tutorials and documentation, and there's actually also a discussion forum. So it's extremely powerful and it does a lot more than what Ramon gave you a taste of. But you can really, if you want to advance your CloudCompare skills, there's a lot of good documentation out there to dive into.
Absolutely. Yeah, let me put the CloudCompare. Right. All right. Well, maybe let's bring our session to a close with our gratitude to participants, and we'll see everybody next week.